Okay. Do I have sound? I have sounds. Oh. All right. What? Jeffrey, Ardelia, Angela. What are you guys? That's right. I have you on by name on video. Later, you're going to be going through your old lectures looking for wisdom. And all you're going to find is a reminder of your shame. And then wisdom. This is the wisdom part. Hi, future Ardelia. How you doing? That outfit you're wearing? Stunning. All right, so this is based on a probabilistic model. What are you doing? Can you read? What's on there? What does it say?
Ruby object oriented. Ha! Hello, future Jeff.
All right. There's. Am I not there? What?
You're not. So you're not on video.
Ugh. Sorry, I don't show up on Phil sometimes because I'm one of them, sexy vampires. Not to be confused with the bat. Just like there are two species of vampires, and I'm not the bat kind. I'm the sexy kind. All right. Okay. Hi. I appreciate that. Okay, so my face is here. Your faces are here. Let's get going. Ruby OOP. Now, when I was talking about Ruby this morning, one of the things I talked about was Ruby as a OOP language, an object-oriented language. And it is, and then we kind of use it as a procedural language a lot today. But it is meant to be an OOP language. And what that means is that it, the main abstraction that it's sort of expecting you to use is object-oriented programming. It's basically organizing the behavior of your application into object definitions. And the preferred method of creating object definitions in Ruby is no, not a literal, not an action. There we go. Class. Finally, the classy answer. Okay, and so how was one way that we defined sort of extra behaviors for an object, behavior of an object in JavaScript? What was the, Yeah, but where would we attach those methods to before the class keyword? The prototype, right? And even the class keyword was really just syntactic sugar on top of the prototype. So in Ruby, that's a bit like this is a class first kind of OOP language. So, yeah, so when you get to Rails, when you get to start building something of any size in Ruby, we're going to be finding that, okay, I'm going to close this door. When we get there, we're going to be using classes to kind of abstract away. Like basically one of the things is when you have a small program, it's easy to have like, oh, I just have a thing here and I have a thing there, right? And then things get bigger and you're like, you know what? All of the stuff that has to do with this, I'm going to go put in this one big bucket. It's kind of like you have like the dresser drawers. You have one piece of furniture whose sole purpose is clothes. You have a closet. You have a small room in your room whose sole purpose, for the most part, is clothes. I mean, you can put other stuff in a closet, but you know what I'm saying? Huh? Right? You may have a bookcase whose sole purpose is books. You know what I'm saying? So it's like you have places like, oh, I have a bunch of this. I got to get something to put that in. And in Ruby, we're going to be organizing these into classes. So I just wrote in Ruby. That's all I had there. So let's talk about classes. Yeah. So the form of a class is pretty simple. You will say class, and then the name of your class. Bourgeois. I get it, because there. I also like how you went for like the definition. Like I'm pretty sure this is a definition straight from Das Kapital, but that's fine. Yeah, we have the class bourgeois, and we are able to now instantiate a member of the bourgeois, an instance of the bourgeoisie, right? So that's as much as I appreciate the Marxist jokes, full Marx really. But so what are we making classes of? What's our okay? I guess we'll have wizard. All right, I agree with this. This is fine. So wizard, right? So we want to define a wizard within the context of our application. We may have. So what will we have on a wizard when we create a wizard? Okay, I'm going to start with. Okay, I want to make a new wizard whose name is Harry. So what? So wizard.new, as opposed to anything else. So now we have wizard.new. That's right, we're going to PP Harry. Get it out of your systems. Oh, no PP for you. Honestly. Right? So we have this wizard object. Let's do a puts, see if we get any more interesting information. Nope. So yeah, you're a wizard, but we have nothing associated with it. One of the things that we have with objects, especially with data objects in our app, is that we want to be able to associate some data with them. When you guys made library, yeah, that's basically what the idea is. Let me see. Puts Harry. Yeah. Right. I think those are some correlation. Although this is in hexadecimal, I'm trying to think how to do hexadecimal. Davey, off the top of your head, do you know how to do an X? Never mind. You're like, cool story, and he's gone. All right. So Harry _ID. We'll get there. Anyway, so we have Harry puts Harry.id. Okay, but I want to actually have some information with this, right? How do I add data to this? How do I get data from this? So we need to start creating some way of adding attributes. And one of the ways that we would do that when we were doing like library and playlists on Friday was that we would put that stuff in the constructor, right? So we need a constructor. I need a constructor. So how do I create a constructor in Ruby? Top of the class. I know. What's your house? Yeah. 5 points to Hufflepuff. All right. Just trying to. I thought so, but you don't necessarily want to sort people into Hufflepuff if they're not ready to accept they're Hufflepuff. I'm definitely Hufflepuff. So I can add. So this is a method to which I can add things. All right. So now we have definitionalized name, and I can say. Well, if I run this, it's going to be like, hey, wrong number of arguments, given 0, expected 1. So I need to put in a name in here, like Harry Potter. Wait. Potterson. Because, copyright. Yeah. So now, we're able to do that, but we haven't really got any information here. So we need to actually associate this with this object somehow. And this is where something called instance variables comes into play. Now, the way I kind of think of these is that where you see the @ symbol, you can kind of think this dot. You can, like, that is a useful, but not actually accurate thing to say. So in the CoffeeScript language, so in the CoffeeScript language, if I were to make a class, and this has kind of been my how does things work? I'll just do it in CoffeeScript, see what I have. Yeah, so class wizard, right? And I think, is it constructor? Yeah. What I could say is @name equals name, and it's mad at me because, right. So they had that similar thing, @name equals name, and it becomes this dot name equals name. So you can think that we are now associating where this object has an instance variable attached to it of @name, right? Which is pretty easy. So over here, if I said Harry equals new wizard, and I said console.log harry.name. Well, sorry. I'm sure it did. To alert. Harry Potter, please don't sue, right? So let's see that work here. If we save this and we run this, @name equals name, right? So we're now taking the parameter name and we're assigning it to an instance variable. Okay, and we can see here, here's that wizard with name is Harry Potterson, right? Okay, so now we have assigned, which means that we should just be able to put Harry.name and see that name that he obviously has, right? Oh no, undefined method dot name for wizard name Harry Potterson, no method error. Okay, instance variables, instance variables are private by default. It's not even that they're private by default, it's that there's just no way to access them directly. We have to make a way to access them directly. So let's do that. I can create a thing called def name. This is a method, and just say, hey, return name. Cool, Harry Potterson. Yes. You could create. There you go. Or Okay, and we'd have to have some way of like letting an assignment happen. So, yeah, that only happens when you create a new wizard. Ruby assignment. Just going to, yeah, cool. So I'm going to say def name. If I want to be able to change that later, then I want to be able to, I have to have something like this. And, right, this is that assignment. So I can say Harry.name equals, or even plus equals, please don't sue. Harry Potter, so please don't sue. Okay, so we have, yeah, so this is our way of creating a full set of methods. I'm going to at least capture this in the notes, right? Hi, Alethea. All right, so, because it was in the notes, so that's why I had to say that. Okay, but there is a shorthand for this. There's something that we can do to create this automatically in just one line. Thank the Almighty. And those are attribute readers, writers, and accessors. So I'm going to create something real quick. Adder accessor. And this says, I want you to create. So this is kind of like a method being called that helps us create this class. And what this does is it creates this method and creates this method automatically. Here? I think it would override it. Yeah, that sounds like a thing. Yeah, probably. Yeah, well, the reason I have this one's a getter and this one's a setter. Oh, yeah, you're cool there. Oh, like, okay, yeah. I think if you're going to overwrite, you would overwrite it in like this. If you wanted to have special, like, I want it to be named, but I want it to be something special, maybe you wouldn't write the, you would write an adder writer and then write a special getter. Yes, okay. So now that we have that, Harry Potter, so please don't sue. So this is, what basically happened is this said, oh, I've been passed the symbol name. I'm going to find an instance variable called name, and I'm going to create a getter method and a setter method, both called name. Well, one called name, the other one called name equal. Yo.
So if you had a whole rack of things you wanted to put as parameters in your initializer,
Yeah.
would you have like you follow this kind of order?
I don't think it matters which order I follow.
Just match the right values.
Yeah. Take that off for a second.
And
Oh.
you could like pick and choose what you put in your accessor.
Yes. Totes. No, because the double at's for like, yeah. Yeah. I'm going to stay away from the statics just because statics are a thing. Okay, so this helps me create, so we've also seen how to create methods on a class, right? I'm trying to think of where I want to go with this. I guess the next thing to talk about will be inheritance. I'm going to talk about inheritance, right? So Ruby, actually CP, classes, inheritance.rb. Okay, so I have a wizard. And let's say I want a more specific kind of wizard. I like everything about the basic wizard, concept, but I want to add another thing on top of it. I want to add another ability. So what I'm going to do is I'm going to build a new class. And that class is going to be Animagus. And basically what I want is to say, every Animagus is a wizard, not every wizard is an Animagus. Right? So it's going to be like this. Okay? And, okay. Remus is a werewolf. Tonks is like a partial Animagus. Does that even count? She can just change her nose. And her hair. Right. She should change her designation. All right. So, yeah.
I'll let her know.
Sirius Black is Animagus.new. Sirius Black. R.I.P. Oh. Sorry, spoiler alert. I just finished Order of the Phoenix. Or no, I guess Order of the Phoenix is really... I mean, it's fine. Everything's fine. Why wouldn't it be fine? I was just about to finish Order of the Phoenix. All right. So, Goblet of Fire. Who here's just got to Goblet of Fire? Bad news. All right. Everything's fine. Oh, yeah, fair enough. So, puts Sirius. Or should I P Sirius? Yeah, I should P Sirius. Okay. Honestly. Okay, so now I have Animagus named Sirius Black. And everything that it was true of Wizard is true of... So, for instance, I might have... I might give him a set of spells, right? Is nothing. I might say def add spell. So I might also have like adder writer. Oh, adder reader? Yeah. Spells. Add spell. It's Leviosa. Sorry. Or no, it's, yeah, whatever. It's Leviosa, not Leviosa. All right. So, spells dot, is it push? That can't be right. Yeah, it's probably right. But it can't be. But it probably is. Cool, cool. So we're going to say Sirius dot add spell. Right? So we didn't define that on Animagus. We defined that on Wizard. Yeah? Okay. But what if we want to define something specifically for Animagus? Right? We want to have some. So let's go. So for instance, I'm going to expand the initializer here. Does everyone know what an Animagus is? Is someone not clear what an Animagus is? You could admit it. This is a safe space. So in Harry Potter, Harry Potterson, in our off-brand Harry Potter series, an Animagus is a wizard that can turn into an animal while still retaining their selves. So a werewolf becomes like a wolf. Becomes like a wolf like inside, right? Whereas an Animagus can be like a cat but still retain their, Professor McGonagall can be a cat and then she's like still like who she is. She doesn't like eat mice. Or if she eats mice, it's because Professor McGonagall wanted to eat mice. Right? So, you're right, Calgary. This is very silly. All right. So what I'm going to do is I'm going to expand this initialized name animal. Right? Now, let's say that I didn't know what I was planning on doing with name. Maybe name goes into a database or something. I don't know. There could be some secret sauce here that happens in the name. I know that every wizard has to have a name. So what I want to do is I want to call my parent constructor first. super name. This calls the constructor of wizard on this thing. It does all the constructor of wizardy things. Including making a spells array. And then I can say @animal equals animal, right? And you can't change your animal after it is set. So, as far as I can tell. So, I'm going to add @adder reader animal. Okay, so why not do super name equals name? So what we're doing is we are calling that constructor function. We're calling that parent initialize function on this item, creating a few things, and then we're kind of doing our own thing. So it is a function we are calling, if that makes sense. We'll kind of go through it and you can kind of see. Render. Oh, what did I do wrong? I apparently don't have. Oh, there we go. Given one is with 2. Right, so Sirius Black here, we have to say dog. Sirius Black will appear as a dog. That's his thing. So now, what does Animagus have? In fact, let's take this into Ruby Tutor, because it has a good visualizer for this. Okay. So we have the wizard class that's going to be created. Right? There's wizard. It's going to go through. Wizard's going to get, I'm going to kind of zoom out here for a second. Adder accessor name. So now it's going to get a name method and a name equals method. Cool. Adder reader spells. We're going to get a spells method. Initialize is now created. Add spell is, well, added. Right? Cool. Now we have the Animagus class. Adder reader animal. Initialize. So it has its own initialize. You'll notice that I did not add a name method to Animagus, right? I did not add a name equals method to Animagus. I did not add a spells method to Animagus. I did not add a add spells method to Animagus, right? I don't need to. It already exists on Wizard. So it's just going to be like when I call, so, okay, create a new wizard. Harry name plus equals don't sue, right? So here we create, here we go to Animagus, its constructor, initialize with name and animal. We call super name, and this is going to take us up to the initialize method of wizard, right? Set name, set spells, end. And then we're going back here, finishing up our own constructor @animal equals animal, end. Sirius.addSpell, Alahomora. Now when I say add spell, that add spell is still a method on wizard, right? Okay. Yes. So when we call super, if we call super from the initialize method of the super of the subclass of the new class, then it's going to call the initializer of the other one. If we had an add spell, like maybe we for Animagi, we're going to go Animagi. So if we had one for, what would be Animagi? You know what? Well, it would be Animagi in Latin, but clearly this is not a Latin word. So Animagi. I'm going with Animagi. So if we had an add spell class for Animagi, maybe we want to say like, oh, this is a spell that you can do as a dog, but this in your animal form, or this is a spell that you're going to do in your human form, right? So maybe you have some spells you can actually do in your animal form. Right. Right. So, we just covered whether or not Animagi could do spells in their animal forms. That's all you missed. So I might have some sort of thing that I would do, but then I have a parent class there. Or I might, so from my add spell, if I say super there, I'm going to be calling the add spell of the wizard class. The method being called. So whenever I call super from a class, it is always calling my parent's version of that method that I'm overriding. So when I say overwrite, I can either just completely copy over, like, oh, I'm doing this way, totally ignore what my parent is doing. I can use a bit of that parent logic and still do my own stuff. Or I can not write anything at all and just use my parent version of that. Okay? Right. I do and say silly things for money. Okay. Inheritance. Reflection. So reflection. When we're talking about code, reflection is basically being able to inspect and find things out and reason about the structure of code at runtime. Basically, those sorts of things that we knew while we were kind of writing the code, we can find out about at runtime. So while we're going, we can kind of inspect the logic of the code that we are using, which seems weird. So let's kind of take a look at that. So reflection, I have wizards, I have Animagi. I'm going with Animagi. That's just what I'm doing. I'm going with basically an Italian pronunciation, but not like a comical, not like a stereotype like Animagi. What's the matter, you? Like that, just Animagi. Basically, church Latin pronunciation of Animagi. Is that an ecclesiastical Latin of Animagi? Are we going to go with that? Jeepers. Okay, so we have Harry and we have Sirius. Can we all be serious for a moment? So I want to be able to, if I got something into a function, I want to be able to know things about it. So I'm going to say function, not function. That's not how we create functions. Def reflect on some value. Yeah. So, and then I'm going to call reflect Harry, reflect Sirius. Oh, and I'm probably going to do a okay. And also because I can do that. I think I just kind of like that I can. I don't know. You can decide whether or not that's comfortable for you. Right, reflect value. So what I can do is I can do something like, a simple one would be, I'm going to use the p tag, value dot methods. Given a value, I can take a look at its methods. So let's do that. Let's just start with Harry, and then we'll look at Sirius in a moment. Can we be serious there? All right. Ruby reflection. Okay, wow. Everyone. Yeah. I like how you go directly to the tank. That was... There's just singleton, display... There's trust. You don't care about trust. He goes Ugh. All right. So name equals spells add spell. All right. So you'll notice the first one it led with was stuff it got directly from wizard, from the wizard class. And then instance of, kind of, is a, tap, public send, public method, singleton method, remove instance variable, define singleton method, instance variable set, extend to enum for, the comparison, the triple equals, the weird equals, the different weird equals, equal, respond to, freeze, inspect object ID, send display 2s. Does anyone have any idea what 2s does? It's toString. That's right. Nil, hash, class singleton class, clone, dup itself, tainted? What, taint? I don't Google that, but not in our Wi-Fi. All right, so say Ruby class first. I think you'll be untaint, untrusted, trust, frozen, method, singleton methods. So there's the methods, by the way. That's what we're actually calling. We are calling the methods method, and it let us know that there's a methods method. Blah, 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 blah. And at the end, we can see the bang, the double equals, the bang equals. And at the end there, you can see the underscore, underscore, ID, underscore, underscore. Right? What? Well, that just means that it has a definition. So if I said, like, bang value, seriously. If you could do, okay, I'm just leaving that one alone. All right, so I'm really afraid to use. Okay, so let's. We can also check to see value dot. Let's use that isa, and we can pass a class into this, like wizard. True. Let puts value dot is animagus. True and false, right? I don't know. Well, let's find out. Puts value dot wizard. Well, let's find out. Yeah, it's not a thing. Undefined method wizard. So, so we can see if this is a wizard or is an animagus. I'm going to put a puts at the end of this. Yeah, so now we can see that. There's another one in here that where are you? Tap public method. Maybe it's just, let's see. Puts value dot class. We'll see what we have there. So we have, now we have true false wizard. So Harry is a wizard. And true true animagus. Right? Okay, so now that we have this, we can start seeing stuff about the class. So let's put value dot class dot methods and see what we get. Or actually, let's do a P so there's not like one for every line. Okay, so for Harry, here's his own methods. True, false, wizard. Then we have the ones for the class itself. New allocate superclass. Yada, yada, yada. Oh, man. Lots of stuff here. But here's a cool one. Ancestors. P value dot class dot ancestors. And we can see here, wizard extends object, object extends kernel, kernel extends basic object. Same thing here, animagus extends wizard, which extends object, which extends kernel, which extends basic object. So a wizard is an object, an animagus is an object, right? Cool. So yeah, and then we have, I also notice that we can do new here. Yeah. I wonder if I want to go. I don't know that I want to do statics. But this is a way that we can, like, when we get stuff in, we can actually investigate about it. So this is a great way when you're kind of like getting some code and you're not sure what's available on it, just to find out, like, okay, what methods are available? What was this? And even we could say, if we could look through its methods before trying to call a method. If methods contains name, call method.name, right? So maybe I'll do that. If value dot methods dot, actually before we start, puts value dot methods dot, this includes, Ruby array has value, dot include name. Let's do that. I see that that's true here. That's true here. So I can say, hey, if value.methods.include name. Now that doesn't tell me much about this method, but that's okay. I can still say, what's value.name? Sirius Black, Harry Potterson. I don't know why I changed only that one. I could do Seriously Black. Well, not. Oh, I got it. All right, there we go. Okay. Yeah. There it is. That's just a name. That's just a name in this universe has the name Wiseau. Like Tommy Wiseau. For all you fans of The Room. Okay. I did not. Oh, hi, Mark. All right. So there is, we've covered a bit about inheritance and how you can override methods. We've talked about instance variables. Instance variables are, can somebody tell me what an instance variable is? It is private. That's an important concept. And it's what's the point of that, of instance variables? No, well, it's so that there's some data that is kept with an instance of this class. Would be more like, yeah, that's exactly what I said. That's fine. Okay, so basically, an instance variable is a variable of an instance. So if you make a class, if you have a class and you make an instance of it, and that class definition has instance variables, then that instance you make will have it. So every wizard that's created has a name. Every wizard that's created has an array of spells. Every animagus that's created also has a name and also has an array of spells, but on top of that also has an animal they can turn into. So it's going to be different for everyone. If I make Professor McGonagall, she's an animagus, she turns into a cat.
Let's say we're using
I don't think that file is what you're going to be thinking about here. Because the point of the instance variable is like, if we have a class definition, that's some code that we're bringing across, then we're going to be able to kind of like do whatever we can with the instance variables as defined in the class, right? And if we bring some other information here and use it to create a new instance, well, based on how the initializers or readers or writers work, it doesn't really matter because it's just some data that we put in there. Are there any other questions about classes? Yeah, I feel like this is kind of all the stuff. Also, what's interesting, by the way, is that let's also do a P for wizard.ancestors. So we have wizard.ancestors, but if we have wizard's class, wizard itself is kind of an object of the class, is like an instance of the class. And so if we look at class.ancestors, we can also see that class extends module, module extends object, object extends kernel, kernel extends basic object. Yeah, no. This will not disrupt your day. Yeah. it's the rank right before general. I did kind of have that joke over the weekend because our mall just opened a Colonel's, like the place that does all the popcorn. And I was like, I did say, I think this is smaller than the one at Metrotown. Maybe this one's a Lieutenant Colonel's. And my wife did the thing where she was like, ha ha. Where she like did the fake laugh and then realized that she actually thought it was funny. And she's like, and then like hated that just happened. You know, fine. Every now and then, she doesn't watch my lecture videos, it's fine. I'll make a joke like that, and what she'll do is that she will try to turn her face just enough that I can't see that she's smiling. She's like, uh-huh, mm-hmm. But I can tell, like, there's this much cheek is being pulled backwards for a reason. And I'm like, I saw you do that. Not getting away from me. Yeah. The other... I know this lecture's not about me and the missus, but then the other night, I'd done something just terribly silly. I can't remember what it was. It must have been brilliant. And I realized she's in the closet, and I figure she's like bending over to like move some stuff around, but I realized like her body is shaking. And I'm like, you're laughing. You are laughing now so hard and don't want me to see it that you are just... And she just hides just into the closet, just runs right into it. I'm like, that's... Okay. Oh, I can't see him that he made me laugh. Otherwise, he'll continue to do that thing that makes me feel good. Ugh. Anyway. So she just knew she was dead to rights. It's hilarious. Huh? Yeah, she's just like, she is kind of embarrassed that she likes the jokes I make. There's a certain amount of that. Okay, another story for another day. Right. So any questions about the inheritance in Ruby? Or, right. Cool. I'm going to remind you of a thing as I'm watching some of this candidate enumeration. What's it? This is still like there's a lot of methods on the Ruby like enumerable, like Ruby enumerable and array. Enumerable just means it just kind of keeps on producing things. An array is specifically an array, right, which has some specific things that arrays can do. And I would suggest using this as an opportunity to get good at using arrays, because they're going to come up. Well, they're going to come up in tech interviews, but also like in the rest of your life as a coder. And Ruby has like a really good set of array methods, you know. And the fact that it has some that change it in place and some that don't, you know, it's got collect, It's got collect, right? So it'd be good to kind of go through and get used to like how like those methods and how to best use them. All right? Yeah. Like that map. Hold on. Yeah. Yeah, chaining array manipulation. Right. Yes. Right. So let's do that for a moment. So for instance, let's say I wanted the squares of all of the odd numbers from here to 100. So I might say that, and I want to print them all out. So the first thing I'm going to do is, well, 0 to 100. Then I can say dot, it's not dot filter, it's select. And what I want to do here, so I'm going to call a select. I'm also going to do a collect to do the map. I think this is actually just, I can just say map, right? And then I'm going to do for each of these, I am going to console log it, right? Now I haven't written any of that code yet because I have to use blocks. But this is how they are being called, and now I'm going to pass blocks to them. The first block, selects, is it takes in a number, num, right? And it says num mod 2 is not 0. So now I have the product of this first operation. In fact, let me actually break it down into a few pieces, right? So range to 100 equals that, right? Odds to 100 equals range to 100 dot select, and I pass that block, right? Squares of odds to 100 equals, I guess, right, odds to 100 dot map, and then the block I'm going to pass to it is just going to say, hey, num times num. Right, that's going to give me a square. And then maybe I want to say squares of odds to 100 dot each do num. I'm going to use the other. This is just the other way of defining a block, the other language for defining that. Kind of like how double quotes and single quotes still both just create strings. This is just another literal way of defining a block. Right? Puts num. So you see how I've done kind of a bunch of steps here. Right? So that's a range. This becomes, oh, good heavens. Whew. This is like watching the upper half of people's bodies in Riverdance. They're just kind of. So if you have a bad seat, there's a bunch of people in front of you, that's all you're going to see. All right, 99. Cool. So then I have all the odd numbers from here to 100, right? And then we're going to map those. So we're going to do a mapping, which means that we're going to start creating an array that has all that. And there we have all the maps, right? So this makes sense. 1, 9, 25, 49, 81, 121, 169, 225, 289, yada, 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 all the way to 9,801, right? So then the next step I would do would be, okay, square of odds dot to 100 dot each dot do puts num, right? And here I just spit them all out onto the console. So what I can do is recreate that with simple chaining, right? I don't actually have to assign it to anything. Like this, right? I could, if that's ranged to 100, then I could say that odds to 100 were just, right? And I could say that, now because of the strictures, I'm going to kind of do it one line at a time, right? But that's a chain. Because select returns an array, I'm going to operate on that array with map, right? And we should find ourselves in the same place. Actually, hold on. Obviously, I don't need that top line anymore. Right? So squares of odd to 100 is still that same thing. We just kind of didn't have to save the arrays between them. And then I don't actually have to save that. So instead of saying this, I'm just going to grab all this stuff here and like that. Yes? Yes, you would save memory by saving the screaming methods. So if I said instead of select, obviously I'm going to have to just call. Select. All right. Yes. Well, okay. So passing it as a function is not straightforward. It kind of has to be declared as a block because of Ruby. There's no point understanding the wheres and whys. Just figure out how to use blocks. I will let you know that if you want to think about why this is the case, it will drive you to madness. You can just use it. It's fine. Yeah. Don't re-engineer Ruby. I'm trying to do your voice. Yeah. So that way we can kind of do a chain. So this is like we're changing the dot select and the dot map to that. Like then we're changing the original that we're working on.
Like a sign that's something like, and if you did select as the
Actually, select won't work now that I think about it, because select is being called in a range because it's an enumerable, but a range is not an array. Once I do dot select, it does become an array, and then I can do dot map, and that's fine. All right, I think I am at my time. Thank you guys very much. Away with you.